Welcome to Spelling Bee Ninja, where we transform learning into an exciting journey. If you're eager to explore the world of science, you're in the right place. Join our community of curious minds by subscribing now for engaging educational content delivered straight to your devices. Today, we're delving into the life and groundbreaking work of James Clerk Maxwell, a scientist whose discoveries unified electricity, magnetism, and light. Let's spark that curiosity as we dive right in. James Clerk Maxwell was born in 1831 in Edinburgh, Scotland, in a family with a strong educational background. His early fascination with the natural world was evident from a young age, as his remarkable curiosity led him to publish his first scientific paper about mathematical curves at just 14 years old. Maxwell's journey took him to the prestigious University of Edinburgh and later to Cambridge. It was here that his talents in mathematics and physics truly shined. Despite his immense intellect, those who knew him described Maxwell as humble and approachable, known for his great sense of humor and the clarity with which he explained complex ideas. His work was so profound that it influenced some of history's most brilliant minds, including Albert Einstein, who stated that Maxwell's contributions had forever changed the world. Maxwell's story illustrates how passion and dedication can lead to groundbreaking scientific discoveries. Before Maxwell's time, scientists viewed electricity, magnetism, and light as independent phenomena. Significant breakthroughs were made by pioneers like Michael Faraday and Hans Christian Ørsted, who demonstrated that electricity could create magnetism and vice versa. However, a unified mathematical framework to explain their relationship was missing. Inspired by Faraday's hands-on experimental work and the concept of fields, Maxwell stepped up to the challenge. He translated Faraday's groundbreaking ideas into precise mathematical equations, revealing that these seemingly separate forces were actually different facets of a singular electromagnetic force. This achievement significantly impacted modern physics and opened doors to concepts such as relativity and quantum mechanics. The cornerstone of Maxwell's achievements lies in what we call Maxwell's equations, which include four essential mathematical equations describing how electric and magnetic fields behave. They reveal that electric charges generate electric fields, magnets produce magnetic fields, and intriguingly, changing electric fields can produce magnetic fields and vice versa. This last insight, encapsulated in the Ampere-Maxwell law, added a game-changing term to the equations, indicating that dynamic electric fields could generate magnetic fields, which ultimately led to the realization that electromagnetic waves could traverse through space. One of Maxwell's most astonishing predictions was that electromagnetic waves, including light waves, travel at approximately 300,000 kilometers per second, or about 186,000 miles per second. This speed wasn't a mere coincidence. Through rigorous calculations, Maxwell identified that light is, in fact, an electromagnetic wave. His insight bridged the gap between optics and electromagnetism, and his equations are highly regarded as one of the most elegant contributions to physics. They represented the second major unification in physics, following Newton's laws of motion and universal gravitation. Additionally, Maxwell's calculations of light speed were remarkably consistent with the experimental measurements conducted by contemporaries like Hippolyte Fizeau and Léon Foucault, providing substantial confirmation of his theories. The implications of Maxwell's work extended far beyond theoretical realms, laying foundations for inventions like radio, television, and radar, demonstrating how theoretical physics can lead to practical applications that define modern life. Moreover, Maxwell's findings revealed that visible light is just a small segment of a broad electromagnetic spectrum, which ranges from gamma rays to radio waves. This spectrum includes X-rays, ultraviolet light, infrared light, and microwaves, all described by Maxwell's equations. Astonishingly, many forms of electromagnetic radiation were not discovered until well after Maxwell's time. Indeed, Heinrich Hertz demonstrated the existence of radio waves only in 1888, and X-rays were discovered several years later by Wilhelm Röntgen. Maxwell's predictions enabled a deeper understanding of the electromagnetic spectrum, which now plays a critical role in various technologies, from medical imaging to wireless communications. Furthermore, Maxwell ventured beyond electromagnetism, making substantial contributions to the kinetic theory of gases. He demonstrated that gas molecules exhibit a range of speeds, following a statistical distribution known today as the Maxwell-Boltzmann distribution. This theory provided a framework to explain properties like temperature and pressure in gases. Remarkably, Maxwell was among the early scientists to employ statistical methods to characterize the behavior of large groups of molecules, setting the groundwork for statistical mechanics, a field that remains vital in various scientific disciplines, including astrophysics, chemistry, and engineering. Maxwell's versatility as a scientist is truly inspiring. His influence did not disappear with his time. Albert Einstein's theory of special relativity, published in 1905, was deeply rooted in the conclusions derived from Maxwell's equations. The notion that the speed of light remains constant for all observers was a critical principle Einstein leveraged in his theory. Reflecting on this, Einstein remarked that Maxwell's work was foundational to his development as a physicist. He regarded it as the most significant advancement in physics since Newton. Maxwell's profound impact spanned into the 20th century, and his equations continue to be fundamental pillars of modern physics. Without Maxwell's contributions, pivotal advancements in technologies that shape our world today, think GPS, cellular phones, and wireless networking, might not exist. As Maxwell progressed in his career, he became the first Cavendish Professor of Physics at Cambridge University, instrumental in designing and establishing the Cavendish Laboratory. Unfortunately, his health began to decline, and at the young age of 48, he passed away due to abdominal cancer. Despite his short life, Maxwell's contributions to physics are so extensive and significant that he is regarded as one of the greatest physicists of all time. The Cavendish Laboratory, which he helped create, became one of the most prestigious research centers where discoveries continue to unfold. Notably, many Nobel Prize laureates conducted research there, including Ernest Rutherford, J.J. Thomson, and James Chadwick. Maxwell's organizational and academic legacy plays a crucial role in ongoing scientific research. His untimely demise represented a significant loss for the scientific community, yet his legacy flourishes in textbooks and ongoing investigations in electromagnetism and interconnected fields. Finally, we can't overlook the lasting impact of Maxwell's equations, heralded as the second great unification in physics after Newton's laws. They cement the foundation for contemporary physics, influencing fields from relativity to quantum mechanics. It's worth noting that the unit of magnetic flux, the Maxwell, mx, is named after him. Additionally, he appears on British banknotes, exemplifying the reverence for his contributions. His work didn't just bring unity to electricity, magnetism, and light, it laid the groundwork for countless technologies that define our modern lives. Radio, television, cellular communication, all of these are legacies of Maxwell's brilliance. His tireless curiosity and unwavering commitment to discovering the natural world set a benchmark for scientists everywhere. As Einstein eloquently stated, the era of scientific endeavor transformed with the work of James Clerk Maxwell. Today, we explored the incredible legacy of James Clerk Maxwell and his unifying theories in electricity, magnetism, and light. From his humble beginnings in Scotland to becoming a cornerstone of modern physics, Maxwell's journey is a testament to the power of curiosity and dedication. His equations not only bridged various scientific disciplines but also paved the way for technologies that shape our lives today. Reflecting on Maxwell's contributions highlights the essential interconnectedness of scientific ideas and inspires us to follow our passions in exploring the natural world. Thank you for joining us on this fascinating journey through the life and legacy of James Clerk Maxwell. We hope you've gained a deeper appreciation for the ways his work has transformed our understanding of the universe. If you enjoyed today's episode, be sure to subscribe to Spelling Bee Ninja for more enriching educational content. Until next time, keep your curiosity alive and continue to explore the wonders of science.